Welcome everyone. Thank you for joining us today for this presentation on Agoric. My name is Chris Bennett and I'm a Developer Relations Engineer at the Agoric OpCo. I'll be guiding you through some of the key concepts and basic principles of Agoric, an innovative platform designed to enhance the development of smart contracts. Our goal with this material is to provide you with a solid foundation in Agoric's unique approach to smart contracts and its core components. Whether you're a seasoned developer or new to the world of blockchain, you'll find valuable insights and practical knowledge that you can apply in your projects. This presentation is structured to cover two main areas. First, we'll dive into the key concepts of Agoric's smart contract framework. And then we'll explore the basic concepts and components that make up the Agoric platform. Let's get started with an overview of our agenda. Here's the agenda for our presentation. We have two main sections to cover. First, we'll dive into some key concepts. In this first section, we'll explore the basics of smart contracts, their structure, and the importance of using hardened JavaScript and how state is managed within contracts. We'll also discuss access control mechanisms, the process and significance of contract upgrades, and how contract governance is implemented to allow decentralized decision-making. In the second section of this first module, we'll focus on some basic concepts that you should be familiar with when coming up to speed on Agoric. This will include an in-depth look at various foundational concepts like mints, purses, payments, and issuers. We'll also cover key terms such as amounts and brands. Further, we'll discuss the concepts of offers and offer safety. And then we'll delve into the Zoe service, which is crucial for deploying and managing smart contracts. Finally, we'll talk about seats and the Zoe contract facet, which are essential for interacting with and managing smart contracts in Agoric. By the end of this first module, you should have a clear understanding of these fundamental concepts and be well equipped to start working with Agoric in your own projects. Let's proceed to the first section and start with the basics of Agoric smart contracts. In this first section, we're going to focus on key concepts related to Agoric's smart contract framework. We'll explore the basics of smart contracts, where we'll define what they are, why they're important, and how they function within the blockchain ecosystem. Next, we'll move on to the structure of smart contracts, breaking down essential components and explaining how they're organized and executed. Following that, we'll cover hardened JavaScript, a secure version of JavaScript used in Agoric. We'll discuss both its purpose and the security benefits it provides. We'll then explore the concept of state in smart contracts, explaining how state is managed by using ordinary variables and data structures. Access control is crucial for ensuring both the security and proper functioning of smart contracts. So we'll look into different access control mechanisms that can be implemented as well. Now, one important aspect of maintaining and improving contracts is the ability to upgrade them. We'll discuss contract upgrades, the role of the admin facet, and how state is preserved during upgrades. And finally, we'll cover contract governance, which allows for decentralized control and executive decision-making over running contracts, ensuring they remain flexible and adaptive to changing needs. This first section is designed to provide you with a comprehensive understanding of these key concepts, laying the foundation for working effectively with Agoric. Let's begin with an introduction to the basics of smart contracts. The smart contract is essentially a self-executing contract with the terms of the agreement directly written into code. These contracts automatically enforce and execute the terms of an agreement when certain predefined conditions are met, and this happens without the need for intermediaries. Smart contracts are a cornerstone of blockchain technology, as they enable trustless and automated transactions and significantly reduce the risk of fraud, as well as the need for third-party oversight. For instance, let's consider a simple escrow contract. In a traditional escrow agreement, a third party holds and regulates the payment of funds required for the two parties involved in a transaction. In a smart contract, this process can be automated. Here's a simple example. Let's imagine that Alice wants to buy a digital asset from Bob. Alice and Bob both agree to use a smart contract for this transaction. Alice then sends her payment to the smart contract. The smart contract holds Alice's funds securely. Bob then transfers the digital asset to Alice through the smart contract. Once the smart contract verifies that Alice has received the asset, it then releases payment to Bob. This is a simple example, but it illustrates the core functionality of smart contracts, automating and securing transactions in a trustless manner. In the context of Agoric, smart contracts are written in JavaScript, leveraging JavaScript's widespread use and familiarity among developers. This makes it easier for developers to create and manage smart contracts on the Agoric platform. Understanding the basics of smart contracts is crucial, as it forms the foundation upon which more complex and powerful applications can be built. Next, we'll dive into the structure of smart contracts and understand how they're organized and executed. In Agoric, smart contracts leverage the familiar and powerful JavaScript language, making it easier for developers to create secure and efficient contracts. Let's break down the components of an Agoric smart contract. First, we have the JavaScript code. This is the logic that defines our smart contract's behavior. Smart contracts in Agoric use hardened JavaScript, which ensures that the code runs in a secure environment, protecting it from tampering and malicious attacks. Secondly, we have the persistent state. Agoric smart contracts manage state using ordinary JavaScript variables and data structures, which are saved and restored across contract interactions. The typical execution flow of an Agoric smart contract involves two main phases: deployment and interaction. Deployment is the process of uploading the smart contract to the Agoric platform. When deploying a contract, developers use the Zoe service, which handles the secure and reliable deployment of smart contracts. And the contract's initial state is also set during this deployment phase. Next, we have interaction with Zoe. Once deployed, both users as well as other contracts will interact with your smart contract via the Zoe service. Zoe acts as a mediator, ensuring that interactions are secure and that they adhere to the rules defined in the contract. Users interact with the contract by making offers, which are proposals for transactions that the contract can accept or reject based on its logic. Given all this information, let's reconsider our simple escrow contract example, this time built on Agoric. Just like before, Alice and Bob agreed to use an escrow smart contract for their transaction. This contract is deployed using Zoe, and its initial state is set. Alice interacts with the contract through Zoe by making an offer to send her payment. Zoe ensures that the payment is securely held by the contract. Bob then makes an offer to transfer the digital asset through Zoe. Zoe verifies the transfer and updates the contract state. Once Zoe has confirmed that Alice has received the asset, it then releases payment to Bob, completing the transaction. This structured approach ensures that smart contracts on Agoric are not only secure, but also easy to manage and interact with. Next, we'll discuss the role of hardened JavaScript in enhancing the security of Agoric smart contracts. In Agoric, smart contracts are written using hardened JavaScript, which is a secure subset of JavaScript designed specifically for building robust and tamper-proof contracts. Let's start with the definition and purpose of hardened JavaScript. Hardened JavaScript is a version of JavaScript that has been enhanced to provide strong security guarantees. It helps to prevent common vulnerabilities that can occur in regular JavaScript, ensuring that Agoric smart contracts execute reliably and securely. There are several key features of hardened JavaScript that make it suitable for smart contracts. Object immutability is the first of these features. In hardened JavaScript, objects can be made immutable. Once created, the state of an immutable object cannot be changed. This is crucial for ensuring that contract code and data are not tampered with after deployment. Another key feature of hardened JavaScript is the endo library. Hardened JavaScript includes this endo library, which provides tools and utilities for creating secure JavaScript environments. Endo ensures that contracts run in isolated compartments known as vats, protecting them from unauthorized access and interference. Now, let's dive into some of the security benefits of using hardened JavaScript. The first benefit of using hardened JavaScript is it prevents unauthorized access. By using immutable objects and running contracts in vats or isolated compartments, hardened JavaScript ensures that both contract data as well as code are protected from external threats. Secondly, hardened JavaScript ensures reliable execution. The security features of hardened JavaScript help prevent bugs and vulnerabilities that could lead to unexpected behavior or failures in contract execution. For example, Let's consider a smart contract that manages a digital asset marketplace. By using hardened JavaScript, the contract can ensure that transactions are executed exactly as intended, without the risk of interference or manipulation by malicious actors. By leveraging hardened JavaScript, Agoric provides a secure and reliable platform for developing and deploying smart contracts, thus giving developers the confidence that their contracts will behave exactly as they expect. Understanding the importance of hardened JavaScript is crucial for building secure dApps on the Agoric platform. Next, we'll explore how state is managed within Agoric smart contracts. Managing state is a crucial aspect of developing smart contracts. In Agoric, the approach to state management is designed to be intuitive and efficient. Let's discuss how state is managed in Agoric smart contracts. Agoric smart contracts manage state by using ordinary JavaScript variables and data structures. This means that you can use familiar programming concepts such as arrays, objects, and maps to store and manipulate contract data. For example, if you have a contract that tracks the ownership of digital assets, you might use a JavaScript object to map asset IDs to owner addresses. One of the key strengths of Agoric's approach is the persistence of state. When a contract's state changes, these changes are stored persistently. This ensures that state is maintained across different interactions with the contract. Here's how it works in practice. When the contract is first deployed, its initial state is set using ordinary JavaScript variables. As users then interact with our contract, these variables are updated to reflect the current state. Agoric automatically handles the storage and restoration of the contract state, so you don't need to worry about manually saving and retrieving data. For instance, let's consider a smart contract that manages a simple token system. The contract might have a state variable called balances. Balances is a JavaScript object mapping user addresses to their token balances. When a user sends tokens to another user, the contract updates the balances object to reflect the new balances of both users. These updates are stored persistently, so if the contract is called again later, it will start with the updated state. This approach makes it easy to write and maintain smart contracts, as you can use familiar JavaScript constructs to manage complex state. Understanding how to manage state effectively is essential for building functional and reliable smart contracts on the Agoric platform. Next, we'll take a look at access control mechanisms, which are crucial for ensuring that only authorized actions can be performed on a contract state. Access control is a crucial component of smart contract security. It ensures that only authorized individuals or systems can perform certain actions on a contract state. Let's start by discussing the importance of access control in securing smart contracts. Without proper access control, malicious actors could exploit vulnerabilities to manipulate contract state, execute unauthorized transactions, or even steal assets. Implementing robust access control measures helps protect the integrity of the contract as well as the assets that contract manages. There are several methods of implementing access control in Agoric smart contracts. One common method is using roles and permissions. Now, this approach involves defining different roles, such as admin, user, or auditor, each with specific permissions to perform certain actions. Another approach is capability-based security. In this model, access to contract functions and resources is granted through capabilities. Capabilities are unforgeable tokens that provide fine-grained control over what actions can be performed. Let's take a look at an example to help illustrate these concepts. Consider a smart contract that manages a decentralized marketplace. This particular contract might have two roles: admin and user. The admin role could have permissions to update marketplace settings, add or remove items, and manage user accounts. Whereas the user role might be limited to actions such as browsing items, making purchases, and leaving reviews. In addition to roles, the contract could use capabilities to grant specific permissions to individual functions. For instance, a capability could allow a user to list an item for sale without giving them access to other admin functions. In Agoric, access control is typically implemented by using a combination of these methods. The platform's capability-based security model provides a flexible and powerful way to manage permissions. To implement access control in an Agoric contract, you define the roles and assign capabilities using JavaScript. This approach leverages familiar programming constructs while providing strong security guarantees. Understanding and implementing access control is essential for building secure and reliable smart contracts. Next, we're going to explore how Agoric handles contract upgrades, allowing you to improve and modify contracts while preserving their state. Upgrading contracts is an essential feature that allows developers to improve and modify smart contracts without losing their existing state. Let's start by discussing the role of admin facet in contract upgrades. The admin facet is a special facet provided by Agoric that gives administrative control over the contract. This includes the ability to upgrade the contract. Using this admin facet, administrators can initiate an upgrade, providing the new contract code while ensuring that the existing state is preserved. Let's briefly go through the process of upgrading contracts in Agoric. Step 1 of this 5-step process is preparation. Before initiating an upgrade, developers will prepare the new contract code. This code includes all the improvements and changes that need to be made in the contract. Step 2 is the deployment step. In the deployment step, the new contract code is deployed to the blockchain. This deployment does not yet affect the current state or operations of the existing contract. In step 3, the upgrade will be initiated. By using the admin facet, the administrator signals that the contract should be upgraded. The existing contract state is preserved and then transferred over to the new contract instance. Step 4 is the transition step. In step 4, the old contract is seamlessly replaced with the new one. Users and other contracts interacting with it will now interact with the upgraded version. And the 5th and final step is verification. After the upgrade, it's crucial to verify that the new contract behaves as expected and that the state has been preserved correctly. One of the key points here is preserving state during the upgrade process. In Agoric, the state of a contract is maintained using ordinary JavaScript variables and data structures. During an upgrade, this state is transferred to the new contract, ensuring continuity. For example, consider a smart contract that manages a token system. The state would include user balances, transaction histories, and other relevant data. When upgrading this contract, the admin facet ensures that all user balances and histories are transferred to the new version, so users experience no disruption. This ability to upgrade contracts while preserving state is a significant advantage, as it allows developers to fix bugs, add features, and improve security without disrupting ongoing operations. Understanding the upgrade process and the role of the admin facet is crucial for maintaining the long-term viability and security of your smart contracts on the Agoric platform. Next, we'll explore contract governance, which allows decentralized control and executive decision-making over running contracts. In this section, we'll explore the concept of contract governance, which is an essential feature for managing and evolving smart contracts in a decentralized manner. Let's start with the definition and importance of contract governance. Contract governance refers to the mechanisms and processes that allow stakeholders to make decisions about the contract's operations, upgrades, and policies. It ensures decentralized control, meaning that no single entity has unilateral authority over the contract. Instead, decisions are made collectively by stakeholders, promoting transparency and trust. Now let's look at some common governance mechanisms used in Agoric contracts. The first of these governance mechanisms are proposals and voting. One of the primary mechanisms for governance is through proposals and voting. Stakeholders can submit proposals for changes or actions related to the contract. These proposals are then voted on by the community, and decisions are made on voting outcomes. For example, a proposal could be made to upgrade the contract, change a parameter, or introduce a new feature. Stakeholders would vote on the proposal, and if it receives the required majority, it is implemented. The second common governance mechanism used in Agoric contracts are roles and responsibilities. Governance also involves defining roles and responsibilities. Different stakeholders may have different roles, such as administrators, auditors, or users, each with specific permissions and duties. Administrators might have the ability to propose upgrades, while users can vote on proposals. Auditors might be responsible for ensuring compliance with the contract's rules and policies. To illustrate all these concepts, let's consider an example of governance in a DAO, or decentralized autonomous organization. A DAO is an organization governed by smart contracts, where decisions are made collectively by token holders. In a DAO, any member can propose changes or new initiatives. These proposals are then put to a vote. Each member's voting power is typically proportional to the number of tokens that they hold. For instance, suppose a DAO wants to allocate funds for a new project. In this scenario, a member would submit a proposal outlining the project and the required budget. Other members will vote on the proposal, and if the proposal receives the necessary majority, the funds are allocated and the proposal is initiated. This decentralized approach ensures that the organization operates transparently and democratically, with decisions reflecting the collective will of its members. In Agoric, contract governance is a powerful tool that allows for flexible and responsive management of smart contracts. By involving stakeholders in decision-making, it ensures that contracts can evolve and adapt to the changing needs and circumstances of the users. Understanding and implementing effective governance mechanisms is crucial for maintaining the integrity and the functionality of smart contracts over time. Next, we'll transition to Section 2, where we'll cover Agoric basic concepts and key components.